Now, solving a 3 by 3 or a three equation system, we still start off by setting up our augmented matrix, and we set it up the same kind of way here. Um, we just have more rows and more columns. And we go through and we look for doing the same kinds of things. I want the main diagonal to have ones. I want everything else to be zeros. So I usually start by getting the lower left corner to be all zeros first. So what I'm going to do is I'm going to take row 2 minus 2 times row 1. And that means row 1 stays the same. But row 2, I'm going to take 2 minus 2, and that's going to give me 0. And then I'm going to take 3 minus 2 times negative 1, or 3 plus 2, that's a 5. And then negative 1 minus 2 is negative 3. And then negative 2 minus 16, that's a negative 18. Row 3, I didn't do anything with. It stays the same. So that gets one of the zeros that I want. And then I'm going to take row 3 minus 3 times row 1. And that's going to give me 3 minus 1, or 3 minus 1 times 3, or 3 minus 3, that's going to be a 0. Let me get these other parts put in here first. Rows 1 and 2, they stay the same. Row 3, that's a 0. And then negative 2 ends up being plus 3, so that's a 1. And negative 9 minus 3 is negative 12. 9 minus 24 is negative 15. So at this point, I'm just going to switch row 2 and row 3. The reason for that gets me that 1 right there along the diagonal. That's a nice thing to be able to have. And then what I'm going to do is I'm going to take row 3 minus 5 times row 2. So first row I haven't done anything with. Second row I'm leaving alone now. And then row 3, well, that's 0 minus 0. And then it's going to be 5 minus 5, so that's a 0. And it's negative 3, and it ends up being plus 60, which is a 57. And then it's going to be negative 18 plus 75, which is also 57. Then I'm going to just divide that by 57. Really nice this way. Gets me one of my rows completely done. Now, it doesn't really matter what order I go through, but I want those top 3 right entries to be zeros. So a couple of ways to go about it. I'm going to do row 1 plus row 2. And that means row 1 becomes 1, 0, and negative 11. Row 2 stays the same, and row 3. Now row 1 plus row 2, this becomes a negative 7. Now I'm going to take row 1 plus 11 times row 3. And that's going to give me 1, 0, 0, and then negative 7 plus 11, that's a 4. And then finally, I'm going to take row 2 plus 12 times row 3, and that's going to give me a the last bit of what I need here, 0, 1, that's a 0, and then negative 15 plus 12 is going to be negative 3. So there's my reduced row echelon form for the matrix, 1s along the diagonal, 0s everywhere else. And that tells me that x is equal to 4, y is equal to negative 3, z is equal to 1, which I would write as the point for negative 3, 1.